All right, folks, welcome back. We're still looking at the gates. We're using WPL software, the Delta software for PLC programming, and we've looked at the NOT gate. We've looked at we started with the buffer. We looked at the AND gate. We started with the buffer. We went to the NOT gate. We looked at the OR gate, and today we look at the AND gate, still using Delta WPLSoft. And remember how we start: either Control N, or we click on that icon, or we drag down on the files tab there, and you can see the new. So we want to start a new program. It is still gates, logic gates. So what I'll do, we are doing the logic gates. All right, put the tag there, select our model. The PLC we have is the SS2, so we click right there, and then we give it a name. This is the AND gate. The WPLSoft Delta WPLSoft AND gate. All right, I've probably named things a little bit different. So what's in the name? So now we need to expand our programming platform there. Click on that AND gate. So we saw with the switch equivalent circuits, it is still the same here. It is just going to be 2. Remember, we said you can click on the F1, or we can hit on the icon there. All right, or you can simply type load, and then you can say, which is LD, by the way, the mnemonic for it, and then I would like to click. Nice and straightforward, gives me the name straight away, and I can say, call this X0. I can call that. Why do I want to give it a name? I could give it a name, but there's really no need. Imagine X0 being called A. All right, let's see. We've got a display the AX0. It looks a little bit not so good, but anyway, this simply says this is the input X0. We name it A. All right, then we have it's a remember, it depends on how many inputs we have. So we're going to do series. It could be 2. It's an AND gate, so it can be 1. AND cannot be 1. I can say U and only 1. So it's either a minimum of 2. It can be 2 input. So I could say come back and add another one there, and call it obviously something different. If I call it the same, it will still be the same as a buffer gate, because it will still be the same. So I call it something different. X1, probably call that B, A and B. We're doing A and B. This is just identifying their input. That is the name for it. That's what I'm using the comment for there. So I could have more. I could have 3. Okay, if it's a 2 input AND gate, I'll be done. If it's 3 or 4 input, I keep adding as long as it's in series. Possibly call that X2. Remember, if it was 2 input, it will only be X0 and X1. But now we want it to be 3 input. We could make it 4. Probably we'll call this C. We could make it 4, 5, whatever inputs we desire, right? So this is a 3 input AND gate. So what we need now, we need this combination to drive an output. So remember, we could just type out, and then we could just click on the icon there. I'd like to just click, and then I could have hit the F7 there. All right, I could have hit what do you call this? I could have hit F7 function, the FN function F7, and then I would name that the output. Let's call that F or Z or whatever you prefer. Let's call it out. That will be our. This is the way we would name this is a 3 input AND gate, and then remember, if I say AND, if I say you and you, it means both of you. If I say you and you and you, in this case there's 3, you and you and you. So in this case it will be A, B, and C. It means all of them. So if you're going to now simulate, you will see that unlike the O, which needed any one, a minimum of one, for of the what causes of the gas to be high, for the output to go high. In this case here, you would need all of them. All right, let's go there and just run once. There you'll see that once I run it once, it shows you all of them are open, so it doesn't give us any report of faults. So we get out and we go and we say, let's rather put it online. Now you can see it's on stop mode. We go and put it on run mode. Now we are simulating. Do you wish to continue? Of course, we'd like to continue. Now you will see that it's on run, but nothing is happening. Now I will engage. I will put this one on, set it on. You can see this one is on. Nothing happens. You can see our Y. Nothing is happening on the Y. Look at the Y there. Let's highlight that. Look at our Y, and you can see it's not on. All right. So now you go and say, let's activate a second one. Let's activate a second one, X1. Remember that X0 could have been any of them. Look, before we do that, let's set this back. Set off. Now let's try X1. Set it on. And you can see again, nothing happens there with the what? Nothing happens with the output. Nothing is happening. You can see this is nothing is happening there. All right, it's not turning on. Remember, green represents on. So we come and say, okay, let's come and try a different one. So none of them is going to, you see that none of them is going to drive this on. Why? Because everyone that is off represents a break in the circuit. So as long as X0 is off and X1 is off, you will see that nothing can happen there. All right, so you require, is 2 enough? You will see that even if I set on 2 of them, as long as there's a break in the circuit. So what does the AND gate look out for? The AND gate looks out for a break. All right, the AND gate looks out for a 0 in the inputs. If there's a 0 in the inputs, the output is obviously going to be 0 as well. All right, only when all of them are on. Now we turn this one on. Now you can see all 3 are on. Now look at your output there. You see your output there is also gone on. It's now green. All right, so the grass is now green on the other side as well. Now this is the case of the grass is green on the one side and the grass is green on the other side as well. Now, as you can see, it's only if all of them are on and there's no break in the circuit that you get an output there. I mean, looking at it, it's supposed to be common sense. Now take this time to tell us where you are. Comment there on the section there, on the comment section there. Tell us where you are. Hit the like button if you like what we just showed you. Now this is the AND gate made easy with Delta WPLSoft, and we are programming is the PLC. There are situations where certain machines need certain conditions to be fulfilled together. All right, let's look at an X-ray machine, for instance, which will require not only that you press the start for the machine to run, but it will also require that the doors are fully closed so there's no leakage of radiation and stuff like that. Okay, so that's a simple example where you at least have to have certain more than one condition met before a machine can run. All right. Remember to subscribe if you're not part of the family yet, but if you are, well, I hope it still feels nice to be part of us. All right, now let's meet on the next session when we look at the next gate. We've done how many so far? Remember, look at the NOT gate if you haven't looked at it. Look at the buffer, the OR gate. Now we just did the what? The 3 input AND gate. It could have been 2 input, it could have been more. All that obviously it will have to correspond with the number of what? Of the X inputs there. All right. That being said, schedule in there. Let me see how to get out again. All right. See you when we meet for the next gate.